In the previous section, we talked about continuity. Now we have to talk about differentiability, which is the ability to take the derivative at a given point. Remember, the derivative is the slope of the line tangent to the curve. So a function is differentiable at x equals c if the following conditions are met. The function is continuous at x equals c, and the f prime of x exists at x equals c. Obviously, if we have a hole or an asymptote, that would not be differentiable. We can't differentiate at a point that doesn't exist. And f prime of x must exist at x equals c. We established that the f prime of x is the limit as h approaches 0 of f of x plus h minus f of x all over h. Now, sometimes it's easier to take a look as to whether something is not differentiable. A function fails to be differentiable at x equals c if any of the following are true. If the function is not continuous, we already talked about that. If the function has a sharp point or a vertical tangent. So let's talk about the sharp point here. Let's say we take the absolute value function, for instance. A very simple example. Remember that the definition of the derivative is the slope of the line tangent at this point. So if we consider the origin here, consider that from the left side we have this slope, and from the right side we have this slope. So we don't have a consistent value for the tangent, the slope of the tangent line. As such, a sharp point is not a differentiable location. A vertical tangent is actually a little bit easier to spot in terms of the algebra, because algebraically a vertical tangent would yield a derivative where we divide by 0, which is not an actual value. Typically, functions with a vertical tangent look something like this, where at this point we have a vertical tangent. A vertical tangent would have an undefined slope, and since the derivative is the slope of the tangent line, we can't have an undefined slope of the tangent line and still be differentiable.